Bismillahirrahmanirrahim. Assalamu alaikum. Today we will start with section 2.6 with the title Limits Involving Infinity. In this section, we investigate the behavior of a function when the magnitude of the independent variable x becomes increasingly large, or we write it as x goes to plus or minus infinity. Let's refer to the graph of this function, the function y equals 1 over x. So the blue colored curve, this one and this one, refer to the graph of the function. So you can see here as the value of x is going to positive infinity, the blue colored line is going down where the value of the function is approximately approaching 0. On the other side, if x is going to minus infinity, a very huge negative number, then the graph of the function is approaching the x-axis from the negative side, sorry, i.e. as x goes to minus infinity, the value of y goes to 0. So in this case, we can say the limit of this function 1 over x as x goes to either positive infinity or negative infinity is equivalent to 0. So we can consider this as a hint or as a theorem. We have to use it. The limit of 1 over x as x goes to plus or minus infinity is equivalent to 0. You can imagine this as if x is growing very, very huge, like a very huge number, and you divide 1 by very huge number, the answer will be 0. So if this very huge number is a positive number, then it becomes 0. If it's also a negative number, 1 divided by a very huge negative number is also 0. So in either case, whether x is going to positive infinity or x going to negative infinity, the limit of 1 over x is equivalent to 0. We have also to remember here the limit of k as x goes to plus or minus infinity is equivalent to k, because k is a constant function, and the limit of a constant function is equivalent to that constant. Okay. Let's see these examples. Find a limit 5 plus 1 over x as x goes to positive infinity. We can apply the sum rule, and we say the limit of this function is equivalent to the limit of 5 as x goes to infinity plus limit 1 over x as x goes to infinity. And from the known limits here, we said the limit of a constant function like this is equivalent to the constant itself. So lim 5 as x goes to infinity is 5, and lim 1 over x as x goes to infinity is 0. So 5 plus 0 is 5. So the limit of this function is 5. The second function in part B, the limit of pi square root of 3, this is a constant, divided by x squared. We need to find this limit as x goes to minus infinity. Well, we can break these into 2 or 3 functions multiplied by each other, like pi square root of 3 multiplied by 1 over x multiplied by 1 over x. So the limit of each function can be determined here. So the limit of the first function, because it's a constant function, will be pi square root of 3. The limit of the second and third functions, 0 and 0. So the final answer will be 0. Okay. Now let's see the limits at infinity of rational functions. Here we have 2 cases for the rational function. So to determine the limit of a rational function as x goes to plus or minus infinity, we first divide the numerator and denominator by the highest power of x in the denominator. This case, which we call case number 1, this technique can be used if the power of the variable x in the numerator is less than or equivalent to the power of the variable x in the denominator. So what we will do as a first step is we divide the numerator and denominator by the highest power of x in the denominator. As an example, let's see this function. It's a rational function because we have a numerator and a denominator, and we need to find the limit of this rational function as x goes to positive infinity. Now, let's see the highest power of x in both the numerator and denominator. We will see the highest power of x in the numerator is 2. The highest power of x in the denominator is also 2. So we can use this method by dividing by x squared, which is the highest power of the denominator. So we divide each term in the numerator by x squared. Also, we divide each term in the denominator by x squared. So if we divide the first term here, 5x squared, we divide by x squared, we will get 5. If we divide 8x by x squared, we will get 8 divided by x. And here we will have minus 3 by x squared. For the denominator, we divide by x squared, we will get 3 plus 2 over x squared. Now, we have to use the known limits. The limit of 5 is 5. The limit of 8 divided by x is 0, because 8 divided by x we write as 8 multiplied by 1 over x. And the limit of 1 over x is 0 as x goes to infinity. So the limit of this function is 0, minus here also the limit is 0. In the denominator, we have the limit is 3 plus 0. So the final answer will be 5 by 3. So always we follow these steps, and we have to use these known limits. Now the second question is the limit of this rational function as x goes to minus 8. Now the highest power of x in the denominator is 3. And the highest power of x in the numerator is 1. So the power of x, the highest power of x in the numerator is less than the highest power of x in the denominator. We can use the same method as in example A by dividing each term in the numerator and denominator by x to the power of 3, which is the highest power of x in the denominator. So 11x divided by x to the power of 3 will give us 11 by x squared, and this plus 2 over x to the power of 3. Here we have 2 times x to the power of 3 divided by x to the power of 3 will get 2 minus 1 by x to the power of 3. Now the first term has a limit of 0. The second term has a limit of 0. So the limit of the numerator is 0. In the denominator here we have the limit of 2 is 2, and the limit of 1 over x to the power of 3 is 0. So the final answer will be 0 divided by 2, that is 0. Okay? So whether x is going to infinity or minus infinity, we have to use this method under this condition, which is written in case number 1. Now in case number 2, if the power of the variable x in the numerator is greater than the power of the variable x in the denominator, here we have to use another method if we want to find the limit of the rational function as x goes to plus or minus infinity. This method is the long division. We have to use the long division. So as an example, let's find the limit of the following function as x goes to plus or minus infinity. F of x equals x squared minus 3 divided by 2x minus 4. See the power of x in the numerator is 2, and the power of x in the denominator is 1. So the highest power of x in the numerator is greater than the highest power of x in the denominator. So we have to use the long division. This is the way we divide x squared minus 3 by 2x minus 4. I hope you are familiar with this technique. So when you divide x squared by 2x, you will get x by 2, and then you have to multiply x by 2 by 2x minus 4. You will get x squared minus 2x, and then you subtract x squared minus x squared is 0, minus 3 minus 2x will be given here as minus 2x minus 3 when you subtract them, yes. and then divide by 2x, you will get 1, and you multiply again, you will get 2x minus 4, you subtract, you will get 1. So here, this rational function using the long division can be written as x by 2 plus 1 plus the remainder, which is 1 divided by 2x minus 4. So this is the answer. This is the answer of division plus a remainder, the remaining term here. We call it remainder, okay? Now, as x goes to infinity, plus or minus infinity, let's try first as x goes to infinity. As x goes to infinity, the first term here is what? If you substitute x by infinity, you will get an infinite number, infinity. Okay, and this term at the bottom here will be 0, because if x is very huge number, 1 divided by very huge number will be 0. So the limit of f of x as x goes to infinity will be infinity plus 0, that is infinity. Now if x goes to minus infinity, if you substitute x by minus infinity is a very huge negative number. Then the first term here will be minus infinity, the second term definitely will be 0, because 1 over 2x minus 4. If x is going to a very huge negative number, then 1 divided by this very huge negative number will be 0. So minus infinity plus 0 will be minus infinity. So this function has two limits. As x goes to positive infinity, it goes to infinity, and as x goes to minus infinity, it goes to minus infinity. Okay. So this is the way we calculate the limit of the function if the highest power of x in the numerator is greater than the highest power of x in the denominator. We use the long division, so we will get an answer which is linear function plus a remainder. Okay, so the remainder will be having a value of 0, and we will see the limit of this function. It depends on the function. Okay, this term sometimes it has a value. Okay, might be 0 as well. Let's see another situation where infinite limits. Okay, infinite limits. Let's look back at the function f x equals 1 over x as x goes to 0. Not as x goes to infinity or minus infinity, no, as x goes to 0. Let's see the function as we approach x equals 0 from right side, means the limit of this function as x approaching 0 from the right side. You can see the function is going to a very huge positive number. This is from the graph. And as x is approached from left side, the graph of the function is going to a very huge negative number. So we can say the limit of 1 over x as x goes to positive 0 or 0 positive, it's infinity, positive infinity. And the limit of 1 over x as x goes to 0 from the negative sign or the left side equals minus infinity. So this function has no limits at x equals 0, because the two-sided limits are different. The positive side limit or the right side limit is infinity, the negative side limit is minus infinity. So the two-sided limits are different, so the function has no limits as x goes to 0. So this is called infinite limits, okay, because the limit of the function goes to infinity. These examples illustrate the rational functions, how the rational functions behave in various ways near 0 of the denominator. Let's see the case number 1, or example number A. The limit of x minus 2 in a bracket square divided by x squared minus 4 as x goes to 2. See here, if we use the direct substitution, what we will get 0 by 0, which is undefined. So what we will do is we will factorize the denominator by using the difference of two squares. So we will get x minus 2 times x plus 2. And then in the numerator, we have x minus 2 in a bracket square, means this bracket multiplied by itself 2 times. So one of these brackets can be cancelled with the similar bracket in the denominator, and the remaining will be x minus 2 divided by x plus 2, provided that x is not equivalent to 2. Otherwise, we cannot divide by x minus 2. So the remaining will be x minus 2 divided by x plus 2. Now, this is, if you use the direct substitution now, then you will get 2 minus 2, which is 0, divided by 2 plus 2, which is 4. So 0 divided by 4 is 0. Okay? 0 divided by 4 is 0. So the answer will be 0. This is by cancelling the 0 denominator. Okay? Now, let's see another example in B. Limit x minus 2 divided by x squared minus 4 as x goes to 2. Again, we factorize x squared minus 4, and then we can eliminate x minus 2 and x minus 2 from both numerator and denominator, and we will get 1 over x plus 2. So by substitution, we will get 1 over 4. Now the third example here is x minus 3 divided by x squared minus 4, and we want to find the limit of this rational function as x goes to 2 plus, means we are approaching 2 from the right side. Well, we cannot eliminate anything from the numerator and denominator, but we still can factorize the denominator in this way. Now, if we use the direct substitution, x equals 2, we will get what? We will get minus 1 divided by 0, which is not allowed because we cannot divide by 0. However, we are not talking about x is equivalent to 2. We are talking about x just larger than 2, greater than 2. It's something like 2.00001. So the difference between x and minus 2 here will be very small positive number, will be very small positive number. And here in the numerator, we will have, if the x is very close to 2, will be almost minus 1. And this number will be almost 4. But we have to remember here, the first bracket x minus 2 is a very, very small positive number. So when you divide minus 1 by a very, very, very small positive number, you will get minus infinity, because you are dividing 1 or minus 1 by a very small number. So you will get minus infinity. In example D, let's approach x from the left side, means x is very close to 2 but smaller than 2, less than 2. So again here, if we substitute x by a number that is smaller than 2 and very close to 2, this bracket will give us a very small negative number. This term will give us what? A very small positive number, because you imagine 2 as minus 1.9999. Okay, so this will give us a very small positive number. This will give us a very small negative number, because x is minus 1.99. It's not very small. The second term will give us a very small positive number, but this will be negative 1, and this will be definitely it's a negative 1. So negative will be cancelled with negative, and then we have to divide 1 by a very, very small positive number, so the answer will be infinity. Now in part E, as we here, we need to find the limit of the same function as x goes to 2. The limit does not exist, because if we refer to C and D, the two-sided limits of this function are different. The right side limit is minus infinity, and the left side limit is infinity, so the limit does not exist. Here, if we want to find the limit of 2 minus x divided by x minus 2 in a bracket to the power of 3 as x goes to 2. If we take a common factor, the negative sign, then we will get x minus 2. This will be eliminated with one of the 3 brackets that multiplied by each other here, and we'll be having minus 1 over x minus 2 squared. Now, as x goes to 2, what will be the limit? Whether x goes to 2 from right side or left side, because ultimately we are going to square this one. The difference will be very small, but when we square it, it will be very small and positive. And then if we divide -1 by a very small positive number, we will get minus infinity. So keep in your mind, if you divide a number like 1 by a very small number, you will get infinity. So if this very small number is a positive number and you divide 1 divided by this small positive number, you will get positive infinity. If you divide 1 by a very small negative number, you will get negative infinity. Okay? I think that's all for this topic. I will see you in the class, inshallah. Yalla, bye bye. Assalamu alaikum.